This video presents the design input methods and options you can use to create stairs using ARCHICAD. When you create a stair in ARCHICAD, you need to start by providing a polygonal geometry input, which will define the stair's baseline. Let's consider the simple scenario of creating a single flight stair. Click once to determine the starting node of the stair baseline. As you now move your cursor, ARCHICAD provides visual feedback on what the stair will look like, including its risers and numbering. Double-click to determine the endpoint of the baseline. A single flight stair is now generated. The characteristics of the stair's input method can be specified prior to starting the creation of the stair, using the input method option in the info box. If you select the upward option, the first click defines the bottom of the stair. If you select the downward option, the first click defines the top. The position of the baseline relative to the generated stair may be specified in the baseline field. This setting works nearly in the same manner as the reference line location setting of the wall tool. The stair's baseline can be on the left side of the generated stair's body, with an optional offset value, in the center, or on the right with an optional offset value. The stair baseline, being a polygon, can be created using the same polygon creation commands as other polygonal element types, such as polylines. After you start creating the stair baseline, the stair pet palette appears. The lower row of the pet palette contains various creation commands. You can click any of these 5 command buttons, or you can press the F key on your keyboard to cycle through them when creating straight or curved stair baseline segments. Stair segments can be set to one of 4 possible values: flight, landing, winder with equal angles, and winder with equal goings. After you start creating the stair baseline, you can switch from one segment type to another in the upper row of the pet palette by clicking the desired option. Subsequent segments of the stair will be of the specified segment type. Alternatively, you can press the G key on your keyboard to cycle through the 4 options. Let's take the example of an L-shaped stair. Its baseline will have 2 segments, and both these segments will be flight segments. How the stair is constructed near and around its intermediate node is defined by the tuning type setting. The first of the 3 possible options is the automatic landing option, which will create a landing at the intermediate nodes of the stair baseline. The Turning Type Options button provides access to options that influence how the landing is constructed. It also provides an illustration of how risers will be arranged around the stair turn. The second option is Winder with equal angles, which will divide the winder into the specified number of risers, with equal angles between risers. The Turning Type Options button provides access to an illustration plus options that influence how the winder is constructed. In this example, it consists of 2 goings. The third option, Winder with equal goings, is a traditional winder, where going values between the risers along the calculated walking line are always the same. The Turning Type Options button provides access to an illustration plus multiple options that influence how this winder type is constructed. After the stair is created, you can select any baseline segment or node and modify its segment type or turning type respectively, as discussed in the clip titled Introducing the Stair Editing Mode in this playlist. Let's consider creating a U-shaped stair. The Turning Type field is set to Automatic Landing. We can see that if we create all 3 segments of the stair as flight segments, risers will be generated on the landing between the 2 intermediate baseline nodes. Therefore, we need to create the first segment as the flight segment. Then switch to the landing segment type in the PET palette, create the next segment, then switch back to the flight segment type and create the last segment. This way, the landing will not contain any risers. From this example, we can see that both segment types and turning types need to be properly specified to achieve the desired stair geometry.